So good evening to all. Is the AV clear for everyone? Say. Thank you. So I am on the preparation of the topic test on infinite series. So mostly Monday morning I will give as a post test to you. You can solve it. And let us begin our today's session on limits and continuity. Simply the topic is continuity. So majority of you have done some of the problems on this concept at +2 level. I hope that we have the clear idea of what is meant by limit and what is meant by a continuous function. Am I correct? X power n log n power x equal to 1. You are asking about that x power n you are asking about this question, right? So if x is equal to 1, it will be 1 by log n whole power p, right? And it is a divergent one. We have solved this problem by using ratio test. We have done it earlier, right? Isn't it? Please check on that. I think we have solved this problem. Otherwise, I will give the solution separately. Log n power -1 minus, okay, it is so in that case, can you apply the Cauchy's condensation test there for it? Can you apply the Cauchy's condensation test there? So you didn't get the result there. So you please post that solution to me. I will give the respective part to you. So if x is not equal to 1, then how to proceed? Is that your question then? Okay, you give the posters, I will do it separately for you. Fine. Thank you. So the idea of this session is, I just want to give the definition of continuity one more time. And what is the approach? Then what are the problem solving techniques for the continuous functions? It mainly consists of the 3 models. And I want to give some illustration on discontinuity of functions. And at the end, we have one part is left, that is for uniform continuity, which is a separate topic. So in today's topic, I am going to discuss about these things: the definition model, techniques involved under continuity, and the discontinuity concept. That is for today's session. Okay. Any more questions for anyone? Thank you. So first of all, if you say that what is meant by limit of a function, if I say that for the function f of x is the limit, so usually you say limit x tends to a, f of x equal to L. Yes, somewhat similar to continuity class of calculus, but it is the approach is different here. We do the different things here, not like exactly calculus. So could you remind me what we have done with calculus class with regard to continuity? Checking the left and right hand limits, isn't it? And verifying if the values are equal, then it is continuous, otherwise not. Fine. So to some problems we will do, for the rest it is different. The concept of continuity here. Okay. However, it takes very little part. At the most, we are going to take 2 or 3 sessions for this concept, continuity. Not more than it, because majority of the problems you have encountered at calculus class. So if I say that limit extends to a, f of x equal to L, so it means that you are calculating the left limit and as well as the right limit, and both are becoming equal to L. So this is the thing you have learned for limit of a function at the point, isn't it? So here in this continuity concept, we will say that for epsilon greater than 0, there exists delta greater than 0 such that whenever 0 is less than mod x minus a is less than delta, implies mod f of x minus L is less than epsilon. So this is how we define the limit of a function. However, the concept is similar. You are taking the left hand limit as well as right hand limit, both must be equal to L. Apart from this, the definition says that if the difference between the real number L and the function is at most equal with a gap of epsilon, if you choose all the points around a within a distance of delta. This is the actual meaning. It means that if you take the point A, you are calculating the limit, you are taking some values after A, some values before A, such that you have a real number L. So whatever the value of x you are taking here, they are almost equal to L with a gap of epsilon. This was the actual meaning here. Is that clear? The definition part? So if you talk of continuity apart from the limit, if you talk of continuity of a function, usually we calculate continuity of a function with respect to a point. So at a particular point, you are checking the continuity of a function. If you say that the function f is continuous, if you draw the graph for f, it is almost coming without any breaks. So that on observing the graph, on observing the graph, we can say that the function is continuous. And usually we will check the continuity at point by point. The main difference between limit and continuity here is, here limit extends to a, f of x is equal to L, where L is any other number for the concept of limit. For the concept of continuity, limit extends to a, f of x is nothing but f of a. Then we say that the function is continuous at the point. So here also we will calculate the left hand limit, right hand limit, and the values are becoming equal to f of a. So if you look at the traditional definition, for epsilon greater than 0, there exists delta greater than 0, such that whenever 0 less than mod x minus a less than delta implies modulus of f of x minus f of a is less than epsilon. So this is the condition we will verify for continuity of a function with respect to a point. You please take a note of it. So if you say that the function is continuous at the point A, it means that you are saying f of x, f of a are at most equal if you take a neighborhood of A with a gap of delta. So this interval a minus delta comma a plus delta, we call it as the delta neighborhood of a. Okay. So if you want to say the function is continuous at the point a, it is enough if you build a relation between delta and epsilon. It is just like the concept of limits in the sequences, where you say that modulus of Sn minus L is less than epsilon for all n greater than or equal to m. So here you are building a relationship between epsilon and term number. Here you are building a relationship between epsilon and the neighborhood value. That's it. That was the whole idea behind it. So while proving a function is continuous at a particular point, by simplifying this expression, we should be able to build a relation between delta and epsilon. That is the main idea. Okay? Is that clear to all? Fine. So let us take one or two problems on this model. Then we go with the approaches, what we are doing actually there. So the first problem I wish to take is just hold on a moment. Here. So let S is equal to R minus singleton 0. The function f from S to R is defined by f of x is equal to x into sine 1 by x. So the claim is f is continuous at 0. In other words, apart from proving continuous, we say that in a different manner. First we prove like this. Let us say limit extends to 0, f of x equal to 0. Let us do like this. Then we go for the continuity part. Is the problem clear? How I am saying? I have defined the function f from the set S to R. F of x is equal to x into sine 1 by x. And my claim is limit extends to 0, f of x equal to 0. Is this clear? So, and I am proving this by using the concept, the definition of the limit, let me say. So, if you observe that for epsilon greater than 0, there exists delta greater than 0 such that modulus of x minus a is less than delta implies modulus of f of x minus L is less than epsilon. So this is the definition of the limit. So from the claim part, I am checking the limit at the point 0 and I am saying that the limit is 0. So here L is equal to 0 and the point is 0. So if you consider the respective values here, what I have to prove for epsilon greater than 0, there exists delta greater than 0 such that mod x minus 0 is less than delta implies modulus of f of x minus 0 is less than epsilon. In such a way, I should build a relation between delta and epsilon. Agreed? Say, are you getting it or not? Fine. So the approach here is, this is the problem I am taking. Claim limit extends to 0, f of x is equal to 0. This is the problem given. It is just like prove that limit extends to a, f of x is equal to L. It is just like similar. The problem itself is asking that prove that limit extends to 0, f of x equal to 0. Is that clear now? Okay. So the approach is very simple. First of all, we need to simplify this expression. So you consider modulus of f of x minus 0. F of x is nothing but our function. Here 0 is nothing but the real number, the limit of the function what you are saying in the climb. So if you consider the value, it is equal to modulus of x into sine 1 by x minus 0 equal to modulus of x into sine 1 by x. So I can say it is less than or equal to modulus of x. Why? Because it is equal to mod x into mod sine 1 by x. And this value is less than or equal to 1, we know. Accepted? Yes or no? So, actually, epsilon greater than 0 is user defined. It is our choice. So, we choose epsilon greater than 0 such that mod x is less than epsilon. We should choose epsilon in such a way. Why? Because modulus of f of x minus 0 is less than or equal to mod x. I am choosing epsilon at this position. So what happens? Mod f of x minus 0 is less than epsilon will be satisfied here. And if we choose epsilon, we should be able to build a connection between delta and epsilon. So since mod x is less than epsilon, if you observe here, mod x minus 0 is nothing but mod x, it is less than delta. Here you got mod x less than delta, here you got mod x less than epsilon. So comparing these two, we choose that delta is equal to epsilon. So by choosing delta is equal to epsilon, the function has the limit 0 at the point 0. This is the definition based approach. It is very simple. We simply consider this part, we simplify the expression. At the end, we will choose epsilon, so that you are building a relation between delta and epsilon. That's it. Okay? Is that clear to you? Any questions? If you have any questions, you can ask. Yeah. Let me say, you give me a value for epsilon to me. Say epsilon is equal to 1 by 2. Right. So it means that f of x minus 0 is less than 1 by 2. If you choose the neighborhood, as we have a minus delta comma a plus delta, I am taking delta is equal to epsilon. So 0 minus 1 by 2 comma 0 plus 1 by 2. So whatever the value x you choose in this interval, if you calculate f of x minus 0, the difference will be less than 1 by 2. This is the underlined idea here. So if you choose epsilon is equal to 1 by 4, then f of x minus 0 will be less than 1 by 4 if you choose any x between minus 1 by 4 and plus 1 by 4. So building the relation is nothing but you are simply saying that with a gap of this much from the point 0, you can take this and this and this. Any neighborhood of 0 you can take. So corresponding to that neighborhood, you are specifying the difference between the image value and the real number is how much varying. That is the actual idea here in setting the epsilon. Is it fine? Any other questions for anybody? Thank you. So while doing the problems, we won't use this approach, but this approach is useful whenever it is difficult to find the limit part. The computation of limit part is difficult. In such cases, we use this definition technique. And one interesting thing I need to specify is, let us take a small example over the same concept. If you define the function, let me say I want to take a simple one. Just hold on a second, I will. Yeah. So you define the function like this. And the value is 0 for x equal to 2. So this kind of problem you did at the +2 level. How to calculate the limit, isn't it? Right. Now what I am saying is, if you calculate the limit there, what is the answer? By calculating the limit, the value is 4. Accepted? Because everyone agrees for that, right? Isn't it? We use the same definition technique here. How to? So here the limit is 4. So we can say that for epsilon greater than 0, there exists delta greater than 0 such that mod x minus 2 is less than delta implies modulus of f of x minus 4 is less than epsilon. So one way is finding the limit, another way is the differentiation technique here. Here also we do the same procedure as earlier. You consider f of x value and 4 value, simplify, build a relation between epsilon and delta. So sometimes it is possible to calculate the limit, sometimes it is not possible to calculate the limit. So in such cases we use this technique. Is the ideology clear? So let us consider like this. Can you give me the value there? By simplifying, it will be x minus 2. So simplify the expression and give it to me. So that you can build a relationship between epsilon and this one. Yes, very good. X minus 2. right? So if you simplify the value is nothing but x minus 2. All of you accept? Right. So choose epsilon such that mod x minus 2 is less than epsilon. The technique is very simple. You consider the function, you consider the limit. Simplify the expression. Whatever the thing which is remained here, you assume that epsilon is bigger than this. That's it. Nothing more is there. Then, after having this position, you compare the original part and this epsilon part so that you can have a relation between delta and epsilon. That is the whole strategy. If we are not able to calculate the limit, means limit does not exist, right? Yes, here we are able to calculate. That is 4. That is why what I am saying, this technique is useful. No, epsilon will not be equal to delta always. It varies from problem to problem. I will take one more problem so that you will have a different idea. What could be the epsilon there? Right. So I am saying, if you want to prove the criteria, if I have given that, show me limit x tends to a, f of x is equal to L. Apart from calculating the old conventional method, that is finding left hand limit, finding right hand limit, and proving that they are equal, you follow this technique. Because this is the actual idea behind the concept of limit. So, if this thing is not known to you, the L value, we should always find the same old technique, finding left hand limit and right hand limit, are they equal or not. Clear? If the question tag, the function, what is the point and what is the limit, all are specified, then to show that apart from calculating the right hand left hand limits, we are following the definition based approach. That is the intention here. Okay? Are you getting the idea or not? Yeah, I will take more problems. Just hold on a second. So take the problem that I have given the problem f of x is equal to x square sine 1 by x for x not equal to 0 and 0 for x equal to 0. Prove that f is continuous at 0. This is my problem. Please take a note of it. After noting, please inform. Right. So if you write the definition, how do you write? Earlier I have calculated the limit, it is the continuous. Please see the difference. So how I am writing the definition? Epsilon greater than 0, there exists delta greater than 0 such that mod x minus a is less than delta, implies modulus of f of x minus f of a is less than epsilon. This is the definition of continuity at the point A. Accepted? Please tell. Now I am substituting the respective values there. So for epsilon greater than 0, there exists delta greater than 0 such that mod x minus 0 less than delta implies mod f of x minus f of 0 should be less than epsilon. This thing I need to consider and prove. So you consider the last mode part, that is modulus of f of x minus f of 0 you consider. It is nothing but x square sine 1 by x minus 0 as per the definition of the function is given there. So it is equal to mod x square into sine 1 by x, and it is less than or equal to mod x square, as sine 1 by x is less than or equal to 1, the modulus value. Agreed? So at the last position we are choosing the epsilon. So choose epsilon such that mod x square is less than epsilon. So you have the two relations. One relation is mod x square is less than epsilon. Another relation is mod x is less than delta at this part. Accepted? The two things. So if you relate these two things, if you choose delta is equal to root epsilon, so you will satisfy the criteria. That's it. So here delta is equal to root epsilon. So if you square on both sides, mod x square is equal to delta square. So delta square is equal to epsilon must be the thing. So delta is equal to root epsilon. But without using this definition, if the same problem is given to you, how we calculate? You calculate left hand limit, limit extends to 0 minus, so that you are substituting the values and finding a number there. And you should calculate limit extends to 0 plus, and you should prove that the two limits are equal. So apart from doing that limit calculation part, is it somewhat comfortable? So this thing is happened. Why? Because in the problem he has defined the function, he has defined at what point we are checking the continuity, so that we have built a relation between delta and epsilon. Is it fine now, the approach? Right. So this technique we use not for all the problems. Whenever the finding limit is a complicated thing. Otherwise, we have the problem solving strategies, and we will do accordingly the same old calculus part of +2 level or BTech level, whatever you call. Is it fine now? So let us take one or two problems, how we usually do finding the continuity of a function. Right. Let me take a problem. Can I erase this? I think this clarifies your doubt. What is delta? What is epsilon? So this technique we won't use, but this is one of the strategies in proving that the function has limit at this point, the function is continuous at this point. This is one of the strategies, that's all. Okay. So I will take one problem which is done by you earlier in the calculus. Just give me a moment. To determine AB values, if the function f is continuous everywhere, f defined by f of x equal to 2x plus 1, x less than or equal to 1, ax square plus b, 1 less than x less than 3, 5x plus 2a, x greater than or equal to 3. You please check on the problem. I think this kind of problem you have done earlier. Have you done this type of model earlier? Okay. Right. Since the function is continuous at every point, since the function values are bifurcated from 1 and 3, or at 1 and 3, we can say that the function is continuous at 1 and the function is continuous at 3. Agreed? So, if you calculate the limits, the value will be equal since the function is continuous everywhere. So, you can say that limit x tends to 1 minus f of x equal to limit x tends to 1 plus f of x equal to f of 1, because the function is continuous at 1. Similarly, the function is continuous at 3, so we can write that limit x tends to 3 minus f of x equal to limit x tends to 3 plus f of x equal to f of 3. Agreed all? Any questions, please? Yes or no? Shall I proceed then? So let us calculate this one. So if we calculate the left hand limit, limit x tends to 1 minus f of x, it is equal to limit x tends to 1 minus, you should take this one, because f of x is defined as 2x plus 1. This will be 1. Yes or no? Sorry, 3. So you calculate the right limit. So you should take this function. This will be a plus b. And if you equate these t, you will get a plus b is equal to 3. Accepted all. So you do the same thing for this part also. So limit x tends to 3 minus f of x, if you consider. So limit x tends to 3 minus, for 3 minus you should take this function ax square plus b, this is equal to 3 minus, so 9a plus b. Limit x tends to 3 plus f of x. If you consider limit x tends to 3 plus f of x, you should take this one, 5x plus 2a. This is equal to, if you substitute 3 here, 2a plus 15. Since the function is continuous, we have this equality. Equating these two, 9a plus b is equal to 2a plus 15. This implies 7a plus b is equal to 15. So you are going to solve these two equations. Then you will get the values of a and b. So you can say that a is equal to 2 and b is equal to 1. So what is the approach we have done here? Very simple, calculating the limits and equating to the function value, since the function is continuous and you have determined the values of a and b, isn't it? So this is the actual procedure or usual way of solving the problems in the limits part or continuity part you call. If you want to say that the function is continuous at a point, you calculate the two limits and the function value, all the three things must be coincided. Now what happens if the left limit and right hand limit are unequal? It is a continuous function, or you can say the function, sorry, it is a discontinuous function, or you can say the function is discontinuous at the point 1. So let us take the case of discontinuous functions and how we are going to define the discontinuity of a function. Okay, so do you want to take one or more problems on this concept, finding the values of a and b? similar pattern? So let us take one problem with a similar model. I think it is also you have done at calculus part. Can I proceed? So have you noted this? Okay. Suppose the function is defined in this manner. Find A, B, C values if f is continuous at 0. So please take a note of this problem. After noting, please tell. Okay. So since it is continuous at 0, left hand limit at 0, right hand limit at 0, and function values, all the three are equal. So let us evaluate the limits one after the other. So if we calculate limit extends to 0 minus f of x, it will be limit extends to 0 minus sin of a plus 1 into x plus sin x by x. So you can write like this: limit extends to 0 minus a plus 1 into sin of a plus 1 into x by x plus limit extends to 0 sin x by x. I think we can write like this. Accepted? For calculating the limit part. Any questions for anybody? So here, this value is nothing but a plus 1 and that value is 1, so is equal to a plus 2. Agreed? So limit extends to 0 minus f of x is equal to a plus 1. Sorry, a plus 2. Now let us calculate the right hand limit. So if we calculate limit extends to 0 plus f of x, limit extends to 0 plus x plus bx square whole power 1 by 2 minus x power 1 by 2 by bx power 3 by 2. So here limit extends to 0 plus. So what I am doing, I will take x common here so that x power 1 by 2 gets cancelled in the total expression. So it will be 1 plus bx whole power 1 by 2 minus 1 by bx. So do you agree for this? Right? Now, to evaluate the limit, I am going to rationalize here. So please take a note of this, then I will go further to this part. If you have noted the first limit, you tell me. Okay. So if you rationalize here, it will be limit extends to 0 plus. By rationalizing here, 1 plus bx minus 1 by do you accept the value? Right. So the right hand limit value is 1 by 2 and f of 0 value is c. So if you equate the three parts, you will get that c is equal to 1 by 2 and equating a plus 2 is equal to 1 by 2, you get that a is equal to 3 by 2. Minus 3 by 2, right? And what we can say about the value b? Because since the function is continuous at 0, you have calculated the left limit, right limit and function value, making it three values are equal. You have done what is the value of c and what is the value of a and what would be the value of b. It was the question mark here. So the thing is, since the term b didn't come in any of the limits, we can say that b is any real number. So we can say that b is any real number other than 0. Because if you take 0 here, it becomes undefined. So you can take that b is any real number other than 0. So a is equal to minus 3 by 2, c is equal to 1 by 2, and b is any real number other than 0. That is the conclusion. Okay. Any questions for this model? So let us discuss one more problem on continuity. However, there are other models also. So for a small variation in the concept, let us discuss about the discontinuity of the function. Then we come back to the continuity. So the class will be interesting then. So you know what is meant to be a discontinuous function. So mainly, if you talk of discontinuity of a function, it is mainly classified into two types. Actually, some questions are taken from reanalysis and calculus as the intersection part, you can say. Yes, these questions are of reanalysis, not only from calculus. So don't see separately that calculus and analysis are different. Both are one way considered. Actually, the real intention here is reanalysis is one way the background of the calculus. To clarify your doubt, I just give one example that so what is the value here? It is just like isn't it? Yes or no? Now my question here is, you are doing the substitution of the limits, that upper limit minus lower limit in this function. So why you have taken that this is the only integration for this function, and why you have applied the limit here? Why not 1 and 2, apart from 2 and 1 in taking the difference? And why should we do for the definite integral in this way only? Why not the other model? Are you getting the logic? If I have said that integral 0 to pi by 2 sin x dx, you are simply saying that it is a minus cos x and you are applying the limits 0 to pi by 2. And why should we do like that? Any guesses from anyone? Say. The thing here is, in real analysis, while doing the concept of Riemann integrability, we will learn fundamental theorem of calculus, or you can call it as fundamental theorem of integral calculus. There you will encounter this problem. Why should we apply the limits and why should we do in this way only? So, but earlier, while doing the calculus problems on this, we simply integrate and you have a function. This is called integrable function, isn't it? Or may I know, anybody has any idea why you were doing in this way only? Any ideology from anyone? So have you known about this fundamental theorem of calculus? Any one of you? So not only this, yes, for doing upper minus lower limit, why should we substitute in this way only? Why not lower limit minus upper limit? And why you are taking only x cube by 3? Why not any other function? Is it clear now? So this type of concepts we will encounter while doing real analysis things. And I can say the concept of improper integrals will come in calculus. I hope so. Some of you have done some kind of problems on it. Again, in real analysis, we will go with the improper integrals, where the function is undefined at some points, and integral minus infinity to infinity, integral a to infinity, this kind of problems we are going to solve. So calculus, real analysis are to some extent they are the same way, not of different. So don't think like that. So calculus doesn't mean that it is only just doing differentiation and integration and limit finding. It is not like that. So you can say calculus is one branch of real analysis, the whole thing considered. So real analysis is just like a backbone. And whatever the properties you are applying for the continuous functions in calculus, the concept and theoretical proofs you are learning in real analysis. Let me say, if we have done like limit x tends to a, f of x plus g of x, and you are saying that it is nothing but limit x tends to a f of x plus limit x tends to a g of x. And similarly for product, for division, etc., also you are doing the same thing, right? And why should we do the same thing and why they are equal? That theoretical orientation you will learn as a part of result or theorem in real analysis. But while doing calculus, we apply the property straight away, isn't it? If you have given limit x tends to a, f of x by g of x, you are simply saying that limit x tends to a f of x divided by limit x tends to a g of x. And the theoretical orientation you will learn in analysis. But the one setback is, for the UPSC concerned, you are not at all learning any theoretical approaches. You are simply learning the problem solving things. The syllabus is confined in such a way. Theorems won't be asked in the exam. Thank you for your listening. So coming to the back, the discontinuity of a function is mainly classified into two types. First one we call it as discontinuity of first kind. Second, you are calling it as discontinuity of second kind. Here, in discontinuity of second kind, since you are calculating the limits, limit x tends to a minus f of x and limit x tends to a plus f of x, among the two limits, at least one limit should be equal to infinity, the undefined value, either minus infinity or plus infinity. So we say that the function is discontinuous at the point a, and we call it as the discontinuity is of second kind if you calculate the left hand limit and right hand limit, at least one of these limits should go to infinity. Okay, is the definition clear? Fine. If you go for the first kind, it is mainly classified into two types. First one is removable discontinuity and the other one is jump discontinuity. So here jump discontinuity means you calculate the left hand limit as well as right hand limit, they are unequal. Here in removable discontinuity, you can say the limits are equal, but not equal to f of a or f of a undefined. So these are the definitions. Is this schematic diagram somewhat useful to you in specifying the discontinuities? Fine. So for each thing, I will take random examples. These examples you can give on your own. However, I will give some useful tips. So, and before going to give the examples, if you have taken an interval, say closed interval AB, please note that if you say that the function is continuous on this closed interval AB, you are checking the continuity of the function at each and every point of this interval. That means the function value is existed at each and every point of this interval. So to specify the continuity of a function over an interval, we define like this. Limit x tends to a plus f of x must be equal to f of a. Limit x tends to b minus f of x must be equal to f of b. And if you take any intermediate point C, then the left limit, the right limit, and function value, all the three must be equal. Is it visible the top or not? I will write here. Limit x tends to c minus f of x is equal to limit x tends to c plus f of x is equal to f of c. So the three criteria must be satisfied. In other words, At the first point, the function is right continuous because the right hand limit function value both must be equal. At the last point, the function must be left continuous. So the left hand limit function value both must coincide. If you take any intermediate point, it must be continuous in either of the ways. So you calculate the left limit, right limit, function value, all the three must be equal. Then only we define the continuity of the function over the interval. We say that the function f is continuous on closed interval ab. Okay? Is the definition part clear? Now let us take some random examples on this discontinuity model so that you will get an idea. So just hold on a thing, I will go for the examples. So one thing is, let us take the same old example how we have defined. You can take it as 0 or you can take it as 2 as you wish. Right. Now earlier, if you calculate left limit or right limit, the value is 4. Accepted? If you calculate limit extends to 2 minus f of x, the value is 4. Limit extends to 2 plus f of x, the value is 4. Everyone agree? And here f of a is defined because f of 2 is equal to 0. But this is not equal to f of 2. You want to consider the limit part also or not required? Please tell. Is it required for you to calculate the limit? Okay. So here, if you elaborate this thing, limit extends to 2 minus f of x value, limit extends to 2 plus f of x value, both are equal. Left hand limit, right hand limit, both are equal, but they are not equal to the function value. So it is nothing but discontinuity of the first kind, and we say that it is removable discontinuity. Is it clear, the example? How we are taking a removable discontinuity? So could you check on the definition? Yes or no? Any questions for anyone over this example? Right. So for the other one, let us take one simple example. Everyone know the signature function? Signature function takes the values. If the value is less than 0, minus 1. If the value is greater than 0, 1. For 0, for x, the value is 0. Have you known that or not? The signature function. We define f of x is equal to x less than 0, x greater than 0, x equal to 0. Could you recollect that? Yeah. So if you calculate the left limit, its value is minus 1. If you calculate the right limit, its value is 1. So both limits are existed and they are unequal. So we say that the function has jump discontinuity. In other words, if you draw the graph, So you can take that earlier its value is -1. So the function is going to take like this, -1, -1, -1, and it is taking 1, 1, 1, 1, 1, 1. The function has a jump here. I think you know how to draw a graph for this. Okay? Right. So this is the example for jump discontinuity. One more simple example which is known to us, we can take. So because little thinking you can get the examples. There is no need to think about the examples. So this function we know. X minus integer part of x. Everyone will know what is meant by integer part. Say. Any queries? So if you take f of x like this, so you calculate limit x tends to 1 minus f of x. So what will be its value? Its value will be 1. Yes or no? Right. So if we calculate the right limit, zero. Accepted? Any doubts in finding the limits to anyone? So you can observe that left hand limit, right hand limit both are existed and they are unequal. So this is the example for jump discontinuity. Okay. I think these examples are sufficient for you in understanding the concept, the types of discontinuity. So let me take the other example for discontinuity of second kind. Shall I proceed? Okay. So if you define that yes, sin of 1 base at x equal 0 can be jump discontinuity because the function will become, please understand, at 0 minus at 0 plus you are getting the values, right? 1 will be -1 and 1 will be +1, minus k plus k you will get sin of 1 by x. So it is the example for jump discontinuity. Exactly. The simple criteria is if we have calculated the limits, both must be existed and both must be unequal. Right. So if you take this example, e power 1 by x, you calculate limit x tends to 0 minus f of x. And you calculate limit x tends to 0 plus f of x. Now you can see that one limit is finite, another limit has become undefined. So this is the example for discontinuity of second kind. So if you want a very simple example, you can just say like this. So you take that f of x is equal to 1 by x minus a for x is not equal to a. F of x is equal to k where k is any number. So for x is equal to a. So if you define like this, if you calculate the left limit, limit extends to a minus f of x, you will get minus infinity. Limit extends to a plus f of x, you will get plus infinity. Accepted? If you calculate the limits. So here both the limits are becoming undefined. So it is also an example for discontinuity of second kind. As and when one of the limits are going to be undefined, we call it as discontinuity of second kind. That is the only logic here. So however, if you expect a question that explain the types of discontinuities with suitable examples, you can consider these things. Otherwise not required. It is just for your understanding the types of discontinuities to be identified. Okay. So do you need any more clarity over this? The types? Okay. Shall I erase this? I think you know the limit part here, how to calculate. Any questions for anyone? For this function, if you apply like this, what would be the limit? If you have a doubt, you simply understand that the limit sign and the power sign, if both are opposite, result is 0. If both have same sign, result will be infinity. So here you are calculating the right hand limit, the sign is positive, and the power sign is positive, plus and plus, both have same sign, so it should be infinity. Here it is positive, here it is negative, opposite signs, it will be 0. Okay, you can just remember a shortcut, whoever have a doubt. Thank you. So let us take a discussion of the problem on continuity of the function. Yeah, this thing you can expect. So the function is defined like this. Please take a note of it. Examine the continuity of f defined by f of x equals to limit n tends to infinity, x power n whole divided by 1 plus x power n into p over x for all x greater than or equal to 0. So since we should verify the continuity of the function at each point, so starting from 0 onwards, at every real number, we should verify whether the function is continuous or not. If it is not continuous, at what points it is discontinuous, that we should specify. That is the whole idea of this problem. And how the function is defined, for the fraction x power n divided by 1 plus x power n e power x, you apply the limit. That value is the image value, the f of x value. In that way, the function is defined. Is it clear? Any more questions for the function configuration? Please tell. Are you clear for it? So, on observing the pattern of the function, since you are verifying from 0 onwards, so we should verify at 0, we should verify 0 to 1, 1 to 2, 2 to 3, and so on. At every real number, we should verify the function is continuous or not. So first of all, let us take that x is equal to 0. Then what happens? If you put f of 0 is nothing but limit n tends to infinity, accepted the value. Now let us check what is the value of f of 1. So this is equal to limit n tends to infinity 1 by 1 plus e is equal to 1 by 1 plus e. Agreed. So what happens if 0 less than x less than 1? Let me say x is equal to 0.1, 0.2, 0.3, 0.4, anything you take. So earlier in sequences chapter or infinite series chapter, you have taken that r power n equal to 0 whenever 0 less than r less than 1. Accepted? If you apply the limit. Can you recollect that idea from the sequences chapter? All of you? So, if 0 less than x less than 1, x power n converges to 0. By converging, you are applying the limit here. So, f of x will be equivalent to 0 by 1 plus 0, nothing but 0. Now, let us check if x greater than 1, then what happens? Since x is greater than 1, 1 by x will be less than 1. So this function, I am going to write it as, if you common x power n here, it will become like this. So on applying limit, it will be 1 by e power x, nothing but e power minus x. Accepted? Since 1 by x is less than 1, again we apply the strategy. Whenever a value is lying in between 0 and 1, if you apply the limit, its value is 0. The same strategy works here. So limit n tends to infinity, 1 by x power n equal to 0. So please check on the limit parts if you have any doubt. Then I will summarize. Any more questions? How the function is bifurcated here? Okay. So if you have taken a note of this, we consolidate the function like this. F of x is equal to 0 if 0 less than or equal to x less than 1, 1 by 1 plus e if x equals 1, e power minus x if x greater than 1. This is the consolidated representation for the given function after evaluating its values. Please check. Yes or no? Right. Now, here the answer comes. If you take the real line from 0 onwards, this is 1, up to this part, excluding 1, the function value is nothing but 0, which is a constant function. So it is continuous. Any questions? right? So if you consider x greater than 1, that means at this position, every number what you are taking here, the function is e power minus x. We know that it is continuous. E power minus x, the exponential function is continuous, so it is continuous. And you know that e power x is an analytical function also, continuously differentiable function, isn't it? Yes or no? And if you observe at the point 1, so the left hand limit, right hand limit, both are different. Limit x tends to 1 minus, limit x tends to 1 plus, the values are different. Because limit x tends to 1 minus, the value is 0. Limit x tends to 1 plus, the value is 1 by e. Accepted? Yes or no? So the limits are existed and they are unequal. So what we can say about this? For the discontinuity part, jump discontinuity. So this is the conclusion. So from closed interval 0 to open 1 and excluding 1, the function is a constant function, so it is continuous. From every real number that is greater than 1 onwards, the function is e power minus x, which is continuously differentiable function, so it is continuous. So we can say x greater than 1 means you are checking at every point, so we write like this. On this interval greater than 1, less than infinity, the function is continuous. Here the function is continuous, and here 1 remains. It is continuous here because it is a constant function. It is continuous here because it is the exponential function. At the point 1, it has jump discontinuity. Left limit, right limit, both are unequal. That is the overall idea. Okay? Any more elaboration you require? Right. So then let us wind up our session here. Before going to wind up, I just want to give 1 minute recap on what we are going to do in the next session, on Monday's session. So if you sum up what we did for today, you have learned what is meant by discontinuity and their types with suitable examples. And coming for continuity, you have learned the problem solving techniques. One technique based on the definition, one technique based on the limits. We have other techniques are there, especially 2 techniques. One is a theorem called sequence criteria. Another theorem, results. So based on some standard results, we say that this is continuous function, this is not continuous function. And if you want to check a function is continuous or not, apart from calculating the limits, definitions, etc., etc., we apply this sequence criteria technique so that we can prove it is continuous or not. That is the whole idea. So these 2 things we are going to discuss on Monday's session. Then we are left with 1 more session. In that we will discuss about uniform continuity. That is the whole ideology about the concept of continuous functions. Okay? Any more questions required? Please understand, in infinite series, you have learned so many methodologies, isn't it? So many tests you have learned. And if a problem is given to you, what procedure you are going to apply? Any procedure which gives the accurate answer, isn't it? Yes or no? However, you have a strategy for this kind of problem. I am going to apply this kind of test and I can decide whether the series is convergent or not. But however, in the exam point of view, after learning all the strategies, you can apply any strategy of your own and you should be able to decide the accuracy for the convergence. Yes or no, you should be able to specify. Similarly, in continuity concept also, you are learning what are the different techniques available to check or decide whether a function is continuous or not. These are the techniques among which you have learned two, and for the rest of the two you are learning next time, right? You can apply any of the techniques. Don't feel that for this kind of problem I am going to apply this technique. Not like that. You can apply any of your own kind, but you should be able to decide this is correct. That's all. Okay, any more questions from anybody? If not, let us wind up our session here and we will meet on Monday.